I'm going to go over a quick tutorial of how this machine runs, operates, and the idea of what we're trying to convey as far as the logic. This machine's going to be cutting 2x6s, 2x8s, 2x12s. The purpose of this product is for columns, for barns. The machine is going to be drilling the holes. It's going to be machining the profile on the end, and it's going to be saw cutting the other end. A system called PT, precision cut on both sides, precision trimming. So the product is going to be laid in front of the machine on a bunk of 2x. The operator is going to take a board, lay a board onto the unit, and then slide them forward into the bend area. They're going to do this 3 times total, and then once the machine starts, they're going to have another board poised and ready. Once the board that's being machined is done, this unit is going to feed forward, and in doing so, push the board that has been machined out, retract. That's when the operator is going to put a new board in, and the system's going to continue. Okay. As this is happening, once it's in the front position, we're going to activate these pneumatic cylinders to hold it in position. We're going to know that the unit is fully forward because there's a sensor, an input here, which is feed, return, and then there's another sensor in the back, which is going to be feed home. Feed home is going to be important because we're not going to want to start any of the machining until we know that the feed is back in the home position. We're also going to want to monitor the clamp. It too is going to have an input, so we know that it's all the way up and out of the way before we start the feed. We're going to know that the clamp is in the down position by the down sensor, so it's down and it's clamped up. We're also going to know that the Z's are in position, but that's going to be controlled through the closed loop servo system. So there is no sensor there, but we are going to have to know that they're out of the way. The fly cutter, which Z is done pneumatically, has 2 sensors on it. The home sensor is when it's completely retracted, and then the other sensor, which is going to be somewhat dynamic depending on the height of the cutter. So when the operator changes the height of the cutter, they will have to adjust the sensor so that the machine will know that it's all the way up. So that's one alarm that I'd like to put in there, so when the Z is all the way up and it doesn't, when we've activated the output to send the Z up and it doesn't make that input, we can come up with an alarm that says that that sensor may not be adjusted correctly, or that the Z hasn't come up, which we'd have to figure out why it didn't come up. On the back over here, there is a flying fence. The fence is pneumatically controlled. I don't have a sensor saying that it's down, but we do have a sensor saying that it's all the way up. We wouldn't want to feed the product in unless the sensor is all the way up. Alright, so we're going to come to the side here again. The operator is obviously going to be standing in front of the HMI and looking at the machine. I'm calling this direction the X. This is going to be the X gearbox. The in and out gearbox is right over there, and we're calling that the Y. Then there are 2 Z's. There's a Z for the router, which is, stay right here and I'll go over there. There's the router right here, and then there's the multi-head drill, which is the, I would call that the second Z. The router itself may eventually have to do some type of coordinated move. The drills will typically always be doing a point-to-point. We're gonna, depending on what type of product it is, this has potentially eight drills in it. If you'll take a look at the drawings that I provided that have the different hole patterns, there will be two products where we're going to have to use one drill bit. This particular drill bit here is a 40 millimeter. Primarily it's going to be these 40s, but there will be one in here which I currently don't have to show you, which is going to be 120. So it's going to be over an inch and a quarter taller than the others. So when we have a situation where there's just one hole needed, this longer bit is going to have to come in and drill the depth of the wood. The wood is obviously 1.5 inches thick before we fly cut it. After we fly cut it, it'll be down to approximately 1 5/16 because we're cutting 3/16 off of it. So that one drill will come through and it has to pecker its way through, so multi cuts through. Once it's through, it'll retract and go to the next position. In the situation where you have the longer bit, but you are in fact drilling all 8, because it has the one bit in there, it'll have to do a multi-step until that one bit has gone all the way through. But then once the 40 millimeters length cutters start to drill, then those two will have to pecker through the board. It's going to be again, it's a lot easier to look at the drawings of the hole patterns. You will notice in those drawings one of them has a hole missing. The customer has agreed to allow us to go ahead and drill that additional hole, even though they're not going to use it. So there's going to be an extra or spare hole, so to say. So if you see that, don't concern yourself. We are drilling all 8. On the 2x6, it's only 5 holes. So what we'll do there is we'll just leave out these 3 drills, and it's just going to go with these. So the offset, perhaps the offset is we're going to determine that this is going to be the 0 point, and that'll also be the longer bit. And then when we go to do the 2x6s, it'll still be referenced from here. We just won't have these bits in it, so the code would be relatively the same. Over here, it's not in yet, but there's going to be the fly cutter. The fly cutter has a 10-inch diameter. The profile of the fly cutter is basically straight across the board. But because of chip out, we may have to be creative on the tool path to prevent from major chip out. So now that I've explained the tooling, basically what's going to happen is the board is going to be sitting here in the bed. The XY, stay right there, is going to position itself where this cylinder can raise itself up, and this is pneumatic. It's going to raise itself up to the bottom of the board. It is a mechanical stop. All we have to do is energize an output, and it positions the location of the top of this cylinder to the top of the bed. Then it's going to stay up. Then this clamp is going to come down, and it's going to rest on top of the board. It's heavy. It's going to come down, rest on top of the board with this still being up. Then depending if it's a left board or a right board, the cylinders are going to activate. I can't push it in, but take my word for it, they move. And the cylinder is going to come in and push the board up against a fixed side. This is going to happen not only on this side, but on the other side. We're probably going to do separate outputs, only because the customer would like to, in some instances, not use the width clamp on the opposite side. And this is something new that just came up. So the unit comes down, sits on top of this, the appropriate cylinder, either left or right, pushes the board up against the datum point, the fence. Once that's happened, up on top here is a locking cylinder. This will lock by disconnecting air to it. Once that's locked, the unit will no longer move up or down because it's rod locked. So then down here, what's going to happen then is this is going to retract. It's slaved to the pallet, so we don't have to worry about hitting it. At that point, the fly cutter is going to come in, do its cut. Then this is going to come back. The router is going to come up on the Z. We're going to route the profile. Then we're going to come over and we're going to drill the holes, peck them through, move over, drill the next set of holes by pecking them through, then retract everything, and then this procedure over on this side is done. While that's happening on the other side, we also have sensors to monitor that our clamp is down or up. This side also has a home sensor and a return sensor. They're completely independent from each other, so they're on separate inputs. We have to obviously make sure that this is in the up position before we feed forward. And over here is the saw. The saw is just pneumatically operated with flow controls to control the rate. It too has sensors to let it know that it's all the way down and to let it know that it's all the way up. To change the angle of the tool, of the saw, we have a pneumatic cylinder that just has pneumatics on it. At this point, there are no sensors. I believe we're going to continue down that path. I don't believe we're going to need sensors for that, because we're just going to energize it. It's going to be one direction, the other direction, and depending on how we fire that cylinder, we're going to have our midpoint, which is 0 degrees. And I believe that to be the conclusion.